I would like to invite the next speaker for this session, Mr. Sumit Agarwal from MLA Industries Private Limited. Sumit Agarwal, Managing Director of MLA Group and IIT Kanpur graduate from the 1998 batch, has 30 years of experience in the industry. He is also MBA in Marketing with a diploma in exports. Under his leadership, MLA Group has risen to a 350 crore turnover company with exports to 53 countries across the globe. Having done a 5-year integrated course in chemistry, he is a scientist by qualification, having an all-round rich experience in product design, application research, and reverse engineering. Ladies and gentlemen, let's put our hands together and welcome Mr. Sumit Agarwal on the stage.
Good afternoon, everyone. Thanks to the organizers of NRC 2024 for inviting us to speak on this very important topic, this innovative product, zinc oxide active. Before I begin the presentation, I must tell you that although this is a wonderful product in the sense that it upgrades your product, improves your quality on the one hand and saves you money on the other, there is a lot of skepticism and stigma associated with its use. So we will address all those issues in our presentation today, and I'll try to make it very interesting for you all presentation. What is active zinc oxide and how it is different from white seal? Zinc oxide active is a synthetic zinc oxide which has 3 to 10 times higher surface area than the conventional white seal or French process zinc oxide, and hence it is more susceptible to forming the activation complex with the accelerator. It has lower zinc oxide content as compared to white seal, typically in the range of 90 to 95% in the higher grades and lower in the economical grades. Active zinc oxide has negligible heavy metals, and hence it leads to better aging properties because these heavy metals are also rubber poisons. There are transparent grades available which are compatible with the production of transparent rubber goods like shoe soles, vial caps, etc., which white seal is not because it has a higher refractive index. The difference lies in the manufacturing process for once. See, active zinc oxide is manufactured by a precipitation route or a wet process wherein you react a zinc salt with an alkali, and this is done under very controlled conditions, and you can change the properties of the product, final product, by changing the reactants concentration, pressure, temperature, RPM, and all these properties. And the heavy metals or rubber poisons are selectively removed one by one through a very complex process, which is a multi-stage filtration. Thirdly, the resulting precipitates undergo filtration, drying, partial or whole calcinations, micronizing, surface treatment, and packing. This process is capital and technology intensive. White seal, on the other hand, is manufactured by a simple process where you put zinc dross, which is a galvanization byproduct, in crucibles. It melts, and when the temperature goes further higher, it catches fire. So it takes up oxygen from the atmosphere and forms zinc oxide, which is sucked into the fume hood, and it gets collected in back filters and cyclones through an ID fan. So when there is a combustion, pressure from the bottom and suction from the top, some metallic unburnt particles of zinc and other metals and some ashes are bound to go into the final product. Let us see the difference between white seal and zinc oxide and how it affects the rubber properties. Surface area of white seal is around 5 square meter per gram, and zinc oxide active different grades are between 20 to 50 square meters per gram, which means they can be used in a lower dosage by 20 to 50%. Heavy metals in white seal are 200 to 3000 ppm, and in active it is always below 20 ppm, which translates into better aging properties and no lead sulfide staining. Free metal particles, or we will talk about this more later in the presentation, which I just told you, they go into the white seal through the manufacturing process. They are present in abundance in white seal, and they are absolutely nil in active, due to which you get a zero microwave curing defect, and there are no oxidation initiation spots inside the rubber matrix. The cost is high for white seal and it is lower for active zinc oxide. Price fluctuation is high in white seal because it is directly linked to the LME or the Hindustan zinc price, and it is slower and lower in case of active zinc oxide. The quality consistency in active zinc oxide is better because it is a synthetic route, and each step can be closely controlled to achieve the desired properties. Whereas in white seal, once the dross catches fire, there's hardly anything you can do for avoiding the heavy metals and other things going into the product. Then there is a full-fledged technical support in-house lab, rubber lab available with us to support our customers and help them to adjust the grades. Although no such adjustment is needed and there is a one-to-one replacement, but still we assist our customers through whatever knowledge we have. Then we have a full range of grades, whereas white seal has only one grade. We have application-specific grades meeting the budget and the quality requirements of the customers. This helps not only our distributors but our customers to achieve the best combination of quality and cost. So coming to the main advantage in a time when the industry is hard pressed to be competitive, this product straight away brings you a saving of 60 to 90 rupees per kg without any compromise in properties and in fact enhancing your quality. Let us see how the figures work. So suppose we take a higher grade of our active zinc oxide T150, which would typically cost 265 rupees a kg, and the dosage is 40% less. So at 60% dosage, the effective cost is 159 rupees per kg, and white seal say it is 215 rupees a kg. So the difference is around 60 rupees a kg. And the lower grades are already lower priced, and there again you get a differential of 60 to 90 rupees a kg. So suppose somebody is using 10 tons a month, there is a direct saving of 6 to 9 lakh rupees in a month. So if the product is so potential and so beneficial, why don't we see more of active zinc oxide? Why are other zinc oxide? Why is white seal the leader? There are several reasons. One is that white seal has been used for decades. So there is a certain, confidence, inertia in switching to another product. And white seal, active zinc oxide conventionally has been very high priced. So it is only recently that the prices have come down and are almost in the same range as white seal. Another thing is that there is a total consumption of around 10 to 15,000 tons of zinc oxide in the industry today in India, and active zinc oxide production is only 2,000 tons approximately. So this is because, as I told you, it is a very complex and lengthy process. So there is not much manufacturing capacity. We are although doubling our capacity shortly, but still we cannot replace all the white seal in the market. Then there are a lot of fake or spurious grades available in the market which are simply made by blending white seal with filler. And a lot of people are doing that and they brand it as zinc oxide active, and this has done us a lot of damage. Whenever we approach new customers and we tell them, look sir, you can use this product to elevate your quality and save cost, they say, no sir, we have already used it from our regular supplier and we did not get good results. So that is because either they have brought a fake grade which does not have the advantage of higher surface area and lower heavy metals, or they have bought a shabby wet process material which again does not have any advantage. Now most rubber industries do not have the facility to check these 3-4 differentiating factors which I talked about, the heavy metals, the free metals and surface area. So during the presentation later we will see how we can easily check these properties at the rubber factory in a small lab so that we can overcome this disadvantage. And hence, these small manufacturers are allured by the lower prices, which results in long-term failure, resentment against active zinc oxide. At the moment, there are only 3 big organized active zinc oxide players in India, and MLA is the largest for high surface area active zinc oxides with a capacity of 1,000 tons per month, which is being expanded to 2,000 tons shortly. And we have a full range of active zinc oxides against all the players, even the imported grades like Pan Continental and Global Thailand, whereas our quality is better than them, our prices are also lower. So these are the tests which the rubber industry can use to differentiate between a genuine active zinc oxide and a fake one. So I will not go into the details because of shortage of time, but in this first test we determine the free metal particles in zinc oxide. It is achieved through a reagent called anthraquinone, and the results are reflected in the form of pink spots at the bottom of a Petri dish where there is a zinc oxide paste. So the number of pink spots present is equal to the number of free metal particles. Sometimes there are few countable pink spots, and sometimes the whole Petri dish is covered with pink spots, as you can see here. And on the left you see active zinc oxide which doesn't have a single speck or a single free metal particle. The second test is determination of lead qualitatively in your zinc oxide. Here again you it is a very simple test. You prepare a solution of zinc oxide and add potassium chromate to it. and lead is precipitated out in the form of turbidity. So on the extreme left, you can see lead is present in huge quantity, maybe something like 1000 ppm or above. If it is slightly turbid, then it means around 500 ppm, and it is a clear, rich, transparent yellow solution. It means in the range of below 60 ppm. And if we want to check exactly, then we have to use either atomic absorption spectrophotometer or ICP machine. So we have 2 atomic absorption spectrophotometers in our company, and each batch is tested for heavy metals before it is sent out. The third and most important test, which unfortunately cannot be done at every site, is the surface area measurement, which is done by BET surface area analyzer, which works on the principle of nitrogen absorption and desorption. So we have 2 such machines, and again each batch is tested. Here is our array of grades, some of the popular grades. So on the top is ZINCOSIL T150, which has a surface area of 40 to 50 square meters per gram, and it can be used up to 50% lower in dosage in most formulations. Second is the transparent grade, ZINCOSIL MLA T80, which can be used in transparent goods. And now comes the proprietary grade, which has the double benefit of being slightly lower in cost than white steel, and also having a higher surface area in the range of 20 to 25 square meters per gram. So this is our most popular grade, and after these are the 2 economical grades which we position against Pan-Continental and Global Thailand, and these are used in as a 1-to-1 replacement for white steel. We have carried out extensive trials in different formulations in our rubber laboratory, in third-party labs as well. And we will discuss some of these tests here. So the first one is in conveyor belts, where we got it tested at Anand Precise Labs in Faridabad, which works in collaboration with Attuned Polymers. Here is the recipe. This is in conveyor belt formulation with 45 PHR of carbon 330 HAF. So zinc oxide active T150, the one which has 40 to 50 square meters per gram, top of the line grade, that was used at 3 PHR, which is 40% lower in dosage than white steel. So in the first column you have MLA T150, and in the last column you have active white steel zinc oxide. As you can see, the hardness is 63 for T150, 65 for white steel, tensile strength 246, 246, elongation 537, 542, modulus at 300%, 106.78 for active, 99.95 for white steel. Abrasion loss, volume loss is 101 for active, 110 for white steel. Angular TS strength is 95.35 for active and 94.21 for white steel. So we can conclude that we can easily replace 5 PHR of white steel with 3 PHR of T150 in conveyor belt formulations with 45 PHR HAF carbon 330. Next, what we did was we tested one of our lower grades, which is a 1-to-1 replacement for white steel in the same dosage. So this time we tested in our own lab in both the cover and the skim recipes. So in the cover, both white steel and MLA 200 were 5 PHR, and in the skim they were both 4 PHR. The MH was 71.1 for white steel, 74.66 for MLA 200 in cover. Scorch time was 1.78 minutes for white steel, 1.81 minutes for MLA 200. Optimum cure time 3.3 minutes for white steel, 3.32 minutes for active zinc oxide. In the skim compound, the MH was 53 for white steel, 54 for MLA 200. Scorch time 1.33 and 1.27 minutes, and optimum cure time 2.68 and 2.53. The physical properties are here. Hardness 63 and 62 in the cover compound for white steel and MLA 200. 300% modulus, 103 for white steel, 101.94 for MLA 200. Tensile strength 194 and 196. Elongation 500, 520. Tear 79 and 76. Abrasion loss 78 and 82. Specific gravity 1.11 for both the compounds. And similarly, in the skim compound, you will see that most of the properties are in the similar range. So I will not go through I will not read out all the results because there are a lot of results. So we will quickly scan through it because I want to reach the sustainability part also. I have been told to adhere to the timeline strictly. So these are the after aging properties as 70 degrees centigrade for 72 hours. You can see that most of them are in the similar range except 300% modulus, which is higher in the case of active zinc oxide. So we can conclude that all the properties are in a similar range when our lower grade MLA 200, which is cheaper, is used in the same dosage as white seal. And this is the reason why industry leaders have adopted this product in their conveyor belt recipes. Few of our renowned customers are Forek, Mahajan, Vaidhan, Sunshine, Somi, Neelkant, Eureka, Apollo, ARB, and many more. Now let us come to the highest zinc oxide consuming segment, which is tire industry. So the reason why active zinc oxide has met with success in the medium and small tire industry and is not used so much in the bigger tire players is because, first, as I told you, it has been priced higher historically. It is only recently that the prices have come to the same range as white seal. And then the big tire manufacturers have a lot of things at stake, so they will take around 1 or 2 or 3 years to complete all their track trials. We have already started interacting, and trials are underway at some of the big tire players. So here what we did was we checked our MLA 900 grade, the grade which I told you has the same or lower cost than white seal and a bigger surface area, 20 to 25 square meter per gram, which is 5 times that of white seal. We used it at the same dosage in tire tread recipe. This was again done in a third party lab. You can see that the values are almost similar. These are the physical properties. The abrasion resistance, tear strength, and after aging properties. We also did the dynamic fatigue or flex cracking test here, and white seal lasted 3,78,000 cycles, and ZINCOSIL MLA 900 lasted 3,81,000 cycles. So we can see that there is absolutely no compromise in properties if you replace white seal with MLA 900 in the tire tread recipe. We have recently also got tested. Very detailed studies have been done at Hasitri, which is the JK Tires Institute, along with the dynamic mechanical properties, and the results have been found very promising. We are sharing it with the tire industry. Next, what we did was we tested MLA 900 at 20% lesser dosage compared to white seal, and this time we tested in tread, carcass, and sidewall, all the 3 compounds. And again, the results were, these are rheographic results. Then physical properties, aging properties. So all were in the similar range, and there is no compromise in any of the properties. Next, what we did was we tested at 40% lesser dosage. So here, there was a slight compromise, and this is the reason we don't recommend MLA 900 to be used in tire tread at 40% lesser dosage. We tested in Hawaii strap recipe. I will quickly have to go through all these slides to reach the sustainability. I have 4.5 minutes left. We tested in high pressure hydraulic hose recipe. NR based rubber molded parts. V-belt based compound. So we have used different dosages of different grades and presented the ones which have good results so that the relevant industry can benefit from the same. Rice roll based compound recipe, we tested the higher grades at 60% and 70% dosage. Here it is interesting to mention that in rice rolls, we even tested our active zinc oxide T150 at 1 PHR, which means 80% reduction in dosage compared to white seal, but still the results were very good. EPDM rubber molded parts. So all these results are in a comparable range, and there is no compromise. That is the reason I was telling you that to replace white seal with active zinc oxide, you don't need to do much of an R&D exercise. It is only internal resistance which we need to overcome, and our rubber team is there to help you to achieve this. Butyl auto tubes, similar results. So these are some of our leading customers in tires and tubes, in molded rubber parts, footwear. This is the packaging of active zinc oxide, which brings me to sustainability. As you know, sustainability has 4 pillars: QMS or ISO 9001, occupational health and safety 45001, environment management system ISO 14001, which again is divided into two main efforts. One is for waste recycling and responsible disposal of the wastes which you cannot treat, and reduction in carbon dioxide emission or energy efficiency. And the fourth is corporate social responsibility. So our humble learnings from some of them were as below. In QMS, we have adopted a 3-tier system in which there is a lab at the shop floor, factory quality control lab, and a central quality control lab which works in coordination with the R&D. So we are able to achieve an almost zero defect in the product that is being supplied to the market. In environment management system, we identified that there are few small steps in which we plan incremental improvement over a span of years, and then there are few big steps which we can take, like moving to renewable energy sources, setting up windmill to replace the power plant energy, setting up solar plants, or moving to biomass-based briquettes instead of solid fuel, coal, I mean. And the biggest thing which the industry can do for reducing their carbon dioxide emission is forestation. Now this can be done in two ways and we are working on it. One is partnering with the government to identify vacant pieces of land and investing in creating dense forest, Miyawaki or otherwise, on those pieces of land. And if you are not able to do that because it is difficult to work with the government, then buy your own piece of land, maybe whatever we can afford, and create forests there. So these are like lungs of the city. You can actually absorb the CO2, जितना भी पाप हम CO2 release करके कर रहे हैं, उसका कुछ part हम यहाँ पर mitigate कर सकते हैं. In CSR, we had some humble learnings, like there are two ways in which you can work. You can either donate money or you can do a self-managed CSR. So when you commit your own time in a self-managed CSR, the kind of satisfaction and happiness that you get is unprecedented. And you have to manage it like a profit center where the profit is not money but the good that you do. And contrary to the popular belief that इस जन्म में करोगे तो अगले जन्म में फायदा मिलेगा, we have seen that the results are almost instantaneous. God is keeping an account of everything and He will pay you back in ways you cannot imagine. Now this brings us to the last part, which is how zinc oxide active is a more sustainable product and how it can help the rubber industry in achieving its sustainability targets. Friends, during the corona times, we have seen how important zinc is to our metabolism and immunity. So ZINCOVIT we all had during corona. In animal feeds, a lot of zinc oxide is going because it is important for animal metabolism. A lot of zinc oxide is going into micronutrients because it is important for plant nutrition. So few years or decades down the line, we want to conserve these resources for the generations to come. We don't want to use all our zinc resources in rubber. So zinc oxide active gives you a very good way to straight away cut 40% of the zinc that is going into your rubber. Second is that zinc, as you know, is aquatic poison. So whenever we use rubber products and they get abraded and those particles are carried into the water streams, they are dangerous to aquatic life. So if you use less zinc, there is a lesser toxicity going into the water. Then cost sustainability, because sustainability is not only for tomorrow, it is for today. So profit management system it helps with. And lastly, it presents a very safe recycling option for zinc ash, which is a hazardous waste classified by CPCB. And the other uses of zinc ash, like zinc sulfate or zinc chloride, they do not remove the heavy metals. So these heavy metals are going into the soil and going back into the plants and fruits and vegetables that we consume. Whereas active zinc oxide separates the heavy metals from the zinc and disposes them to a authorized disposal site. So this is how, by using active zinc oxide, you can add to your sustainability efforts. And in the end, I would once again request you all to shed your apprehensions. We are a team of 5 people here, 6 people in fact, will be here till tomorrow. So if you have any doubts about any detailed information you need about the results, about anything, we are there to help. Thank you so much for your patience, and if you have any questions, I am open to it now.
Thank you. Thank you so much, Mr. Sunil Agarwal. Thank you so very much. And may I now request Mr. Dharmesh Dharani to kindly come up on the stage to felicitate Mr. Sumit Agarwal. Well, ladies and gentlemen, I'm sure all of us had great time listening to Mr. Sunil Agarwal. Can we have a huge round of applause, please, everyone, for Mr. Sunil Agarwal? Thank you so much, sir. Once again, thank you so very much for the incredible presentation. Thank you, sir, for doing the honors.